5, 4, 3, 2, 1.
My name is Muhammad Zahir Abdul Muin, metric number 10133. I will explain about our theory in experiment. The first objective is to determine the relationship between mass and natural frequency. This is our equation that we use. This is moment inertia for flywheel and this is moment inertia for additional mass. The total of moment inertia is plus moment inertia of flywheel and additional mass. This is equation mr squared over 2 and this is additional mass equation ma h squared. We can see this is of r and this is h. R and h is fixed. Okay, this from this equation we can get we can substitute this I in this natural frequency equation and then we can get this expression. This equation is set k over mr squared over 2 plus ma h squared. As we know, Wm is a natural frequency and m is a mass. So as a conclusion, we can get if the mass increase, the natural frequency will decrease, and if as mass decrease and the natural frequency will increase.
Michael Anabanki. My ID number is MC10005. Okay. For our second objective is to determine the decay rate in an underdamped system. This is the displacement versus time graph, and along the dot line is the S, and the peak distance, peak distance is the period T. This decay rate sigma equal to epsilon n. From this formula, we can find that when we put the mass is small, and we will have a decay rate is bigger. When we put the mass is larger, and we will have a decay rate is smaller.
Good afternoon. My name is Muhammad Nakiuddin bin Mak Saleh, metric number MH10014. Our experiment is about the free torsional vibration, single degree of freedom. As we know, this is our bench for experiment. We use this flywheel, and this both ends is the additional mass, and we use this constant shaft which is diameter 5 mm. The sensor we use is the accelerometer, which then connected to the NIDAQ, National Instrument Data Acquisition, and then it connected to the PC, which connected to the software measurement and automation explorer and the Desilet software.
Hi, I'm Yap Shin Yi, MH10016. Today I will present about DaisyLab setup. Okay, this is the layout of our worksheet in DaisyLab. First, we go to measurement, hardware setup to synchronize our DaisyLab with the NIDAQ. Then we go to measurement setup to set our sampling rate and block size. Then we check our time base. Is it same as the one we set? Sampling rate 2000 and block size 4096. For input, we choose the torsion boom in analog NIDAQ. Then we put a YT chart to display the raw data. In scaling, we scale down our gravity to acceleration. From the raw data, we can get our frequency as 1.1 Hz. Then we can set our low pass and high pass filter. For the low pass filter, we set as 1.5, and we undergo integration to get velocity. Then we go to high pass filter, 1 Hz, and then we integrate again to become displacement. We put one more high pass filter, 1 Hz. For displacement, velocity and acceleration, we displace using YT chart and digital meter. Then we record our data. The recorder shows the displacement time graph of our data. Then the data window, we use rectangle and block size 4096. FFT, we use the amplitude spectrum. And then we display our FFT.
Good afternoon. My name is Farahim Imanlah. Now I will present about the layout. This is our layout. This is a YP chart graph for acceleration, velocity and displacement. We will comparing the graph. This is the determinator for the graph. This is the amplitude graph that we get from FFT. From this amplitude graph, we take the value of the peak of the graph for calculating the natural frequency. This is the recorded graph. From this recorded graph, we will calculate the decay rate.
My name is Tan Hongbon. My metric number is MC10011. Let me explain how we can get our decay rate from our experiment. Then, we open the lazy lab and we add read data, recorder, minimum or maximum, and write data. Then, we open the DF file that we saved from previous ones, and that file is our displacements versus time graph. That is. So the function of the minimum or maximums is to record the every peak point of the graph and form a new graph at the end. Then save it as a ASCII file. Then we move to Microsoft Excel, and it will form all the data, come out all the data, and we calculate for ln f. Then plot a scatter graph, and we will get this kind of line, and will form these equations when we add thin line. Then we can know that negative 0.1314 is our decay rate by compared to these two equations. Next, I will show you how we can get our natural frequency from our experiment. Then this one is our displacement versus time graph. Then we take two high peak point of the curve, and we need to find the period between this curve, and we use the cursors. Then we can easily know that the time period is 0.9 seconds. We get the value of the period, so we substitute into this equation. Then we get the value of the omega d. Omega d is the damping frequency. Then we substitute damping frequency into this equation, and we also can get this value, so that at the end we can get natural frequency.